Hey there, fellow makers and creators. This is a course on Fusion 360 and 3D printing, where you will learn Fusion 360 concept and about 3D printing by actually building, printing and making projects. This course is completely project based, where you will learn to build fun projects from scratch step by step.
What is Fusion 360? It's a CAD and CAM based software. So let's first understand what is CAD. CAD stands for Computer Aided Design. Computer help us to create design, from simple design to complex design to complicated shapes, so that we don't have to draw it by hand. Throughout history, people design things from hand. The old chariot in Rome were designed by hands, to the aqueduct in Rome, or the Da Vinci flying machine, to the recent history of 19th century and the 20th century. Old aircraft is designed by hand. Old railways, old cars, old tractors, to the old machines, all were drawn by hands and designed by hands. But nowadays, from last 40 years, all design in CAD. Modern aircraft were designed by CAD. Modern cars is designed by CAD. iPhone designed by CAD. All the modern products is designed in CAD. All the product all around us is designed in CAD. So we still do design, but we have computer to help us, aid us. So CAD is computer aided design. Computer help us, aid us to create design or create any model that we can imagine. Who uses CAD? Aerospace engineers uses CAD. Aerospace engineering is about building of things that fly through air or space. The use of CAD in aerospace industry is vital for the successful creation of innovative aeroplanes, designs and functionalities. Using CAD, the aeroplane can be designed and tested on the computer to see how the air will flow over the wings. The engineer can know how the plane will react to the variable ice, snow or turbulence without endangering people. CAD is used by NASA to design all components for the International Space Station and space flight. Structural engineers use CAD to see how strong building and bridges are. They can use to test strength of material to see how strong it is before to build something out of it. Biomedical engineers developed everything from life-saving ventilators to CAT scan machine to prosthetics or medical implants such as pacemakers. Electrical engineers use CAD to design computer components, which uses everything that has a computer in it, such as phone, car, refrigerator, TV and smart devices. Industrial designers use CAD to see how all our products look, feel and interact with us. Furniture designers use CAD to create plans for kitchens, cabinets, chair, table, etc. Interior designers use CAD to lay out space of the building. They could show the owner different designs so they know what is going to look like before committing to buying materials and furnitures. Architects use CAD to design buildings ranging from residential home to shopping malls to huge skyscrapers. Mechanical engineers use CAD to research, design, develop and test mechanical devices. Mechanical engineers can also make use of simulation to test everything from stress to measuring vibration in order to get the perfect output without having to create and modify real-world prototypes. So hope you realize that CAD has a wide variety of applications, from interior design to biomedical engineers to aerospace engineers, all uses CAD. So then, when you design stuff, came the next part,
that is manufacturing. Manufacturing is making of things, could be anything. So Fusion 360 can also do that. With CNC machining, laser cutting and 3D printing, the design model can be turned into a real life product. So let's understand what CAM is. CAM stands for Computer Aided Manufacturing. Similar to CAD, in this computer help us in manufacturing side of things, which means the Fusion 360 can control the manufacturing side of things by controlling CNC, laser cutting and 3D printing. So CAD focus on design of a product, whereas CAM focus on how to make it. So with the help of Fusion 360, you can create anything that you want. Want to solve any normal household problem or creating the product that changes the world. So with Fusion 360 and 3D printing, you can turn your idea into a reality. Hi everyone, this is our first project that we are going to make. It's a simple puzzle cube. So before getting started, make sure that our settings are all the same. For that, just right click on the top icon and click on Preferences. Then click on Restore to Default. And in this course, we are using millimeter as our unit. You can use any other unit that you want. And then click on OK. You can also change the unit by clicking on the arrow beside document setting and then clicking on this icon, and by that you can change the unit if you want it. Hi, this is our first project. So let's start creating our first project. So to create a new design or new project, you can click on the top right plus icon, or you can click on this icon and create a new design. So to create any 3D model, we first have to understand and master the 2D drawing or 2D shape. So what's a 2D drawing? Any drawing or shape that has only length and breadth is 2D drawing. And when we add height to a 2-dimensional drawing, it's become 3-dimensional shape. So let's start creating with basic 3D shapes. For example, cube, cylinder, cone, sphere, etc. So let's start creating with a cube. So we first have to think in terms of its 2D shape. What do you think its 2D shape is? Yes, it's a square. So in order to create a cube, we first have to create a square. In order to create a square, we have to create a sketch. To create a sketch, just click on the top right icon, and this will open up various planes where we can create the sketch. A sketch is basically where we draw 2D drawings. These are the various planes where we can draw these 2D drawings. And this red line is representing the x-axis, and this blue line representing the z-axis. This cube is view cube. You can rotate it around by holding down the left mouse button and clicking it around. So this is the y-axis. The green line represents the y-axis. So the bottom plane represents the xy plane, and this plane represents the xz plane, and this plane represents the zy plane. So we can create a sketch in any of these plane. So for starting out, let's choose the bottom plane. So this opens up the workspace to create the 2D drawing. This line, as we seen earlier, this line represents the x-axis and this line representing the y-axis, as you can see in the view cube, and this point representing the origin. So to create a square, just click on the square 2-point square button and then click on anywhere and drag it around. Then we have created our first square, and then click on finish sketch. And to see the normal view, just click on the home button beside the view cube to see in terms of normal view. And to zoom in and out, just scroll down the middle mouse button of the mouse. You will be able to zoom in and out. how do you think we will create a cube out of a square? As we have seen, we have to add height to two-dimensional drawing to create a three-dimensional cube. To create a height, we use a feature that is extrude. Just click on it and then drag it up to create a positive height, and then click on OK. The two-dimensional square is being converted to a cube. So now let's understand the basic navigation. As we have seen earlier, to scroll up down the middle mouse button to zoom in and out, and hold down the middle mouse button to pan around the view, and to rotate around the view, as we have seen earlier, we can use the view cube, or to rotate around we need to click the shift button and then click the middle mouse button to rotate around the view. When you are zoom in the model, or when you are to zoom out of the model, you can come to its normal view position by double clicking the middle mouse button. Or when your model get lost somewhere, you can't find it, you can find the model by double clicking the middle mouse button. And there is another way to rotate around the model by clicking on this orbit icon, and you can hold down the left mouse button. You can orbit around the model. You can get rid of the orbit icon by clicking the escape key on the keyboard. You can also pan around by clicking on the hand icon and pan around, and you can get rid of the hand icon right clicking the mouse button and clicking on OK or cancel. Let's move on to the next shape. For example, cylinder. So let's think in terms of its 2D shape. Yes, it's a circle. Similarly, we have to create a circle. In similar way, just click on the sketch button, create a sketch button, and choose the bottom plane. And then choose the circle, center circle, and choose any point and drag it around. And then click on finish sketch. Similar way, we can add height to a circle to convert it to a cylinder. Similarly, we will use extrude function, and we can drag it up to add a positive height, or we can drag it down to add a negative height as represented by negative sign besides 55. And then click on OK. We have created our cube and cylinder. As we have seen earlier, that we can create a sketch in any of these three planes that we have seen earlier. But sketch can also be created in the flat face, any of the flat face on the cube or the cylinder. For example, let's take the top surface of the cube and click on it. Now we are creating the sketch on the top of the cube. Let's take a circle and then click on the point and drag it, and then click on finish sketch. Now you can extrude the circle on top of the cube. Just click on extrude function, and then click on the top sketch, circle sketch, and drag it up, and then click on OK. The sketch can be created in any of the flat face of the cube and the cylinder, but it can't be created in any of the curved surface. It can only be created in the flat face, but can't be created in this cube, the curved surface of the cube. This is the important concept. So from the next video, we will start creating the first part of this cube puzzle. Hi, in this video we will start making our first part of the cube puzzle, the part 1 red, this one. So I want you to think how we are going to create this part. So think in terms of drawing. It's 2D drawing. First we are going to create this shape in the 2D sketch, and then we are going to extrude it till here. And in the second part we are going to create another sketch, this sketch top here, and we are going to extrude it here, as we are going to see next in the video. So hope you have downloaded the project file that was given in the description. If you have not downloaded till now, download it from the description. Then open up the file that was given, and in that you will find the exercise files. Open up, and inside that you will get cube puzzle. Inside that you will get a PDF. Open that up. Then this open up the PDF file. This is the cube puzzle that we are going to make. This model was designed by Comboys. You can check it out using this link in the Thingiverse. And then this is the first red part that we are going to make. This is the drawing. This is the sketch. The bottom is sketch, and this is the side sketch that we are going to use. So let's start creating our design. For that, click on the new design, and then before doing anything, first save the file. Just click on the save icon and then give the name of the file. I am going to name it cube puzzle. Then in location, choose the drop down icon and then click on new project, and then name it anything that you want. I am going to name it Learning Fusion 360, and then click enter, and then choose the new project that we have created, and inside that we will create new folder, and then I'm going to name it project 1, and then inside that we are going to save our cube puzzle, and then hit OK. So now next we are going to create a new component. New component is also known as new part. As in the cube puzzle, it is consist of different parts, the red, yellow, the different parts, orange part and blue part. It's also different parts that make up our cube puzzle. This part are also known as component that we are going to use. For now, just click on new component. We are going to see the components in detail in the future video. For now, name it part 1 red, and then hit OK. This will create the new part. Now next we will start designing our part. For that, just click on the sketch icon and then choose the plane, any of that. We are starting to choose bottom plane. So let's start creating with our sketch. Before creating any sketch, we first have to master the sketching. To master the sketch, we have to master the constraint. Choose the top left icon and then choose point, and then we will create one point. Click on left click on one side and then again left click. So let's start with our constraint with the coincidence constraint. As the name suggests, click on it. As the name suggests, it will coincide the 2 points in one point. Just click on the 2 points. Now the 2 points has coincide in one. So this is the coincidence constraints. Let's see with some other examples. To create a line, just click on the top left icon, this line icon, and then click one and drag it and then click again. You can continuously able to create another line, but we don't want a single line. To get rid of this icon, you can see this tick, green tick. Just click on it. It will get rid of that line. Now we can use the coincidence constraint between this point and the line. If we apply the coincidence constraint between this point and the line, it will coincide with each other. Now it has coincided, the point has coincided with the line. If you want to get rid of the coincidence constraints, just click the escape key in the keyboard. Now the point is coincidence with the line. If you move the point, it will always be along the line. If you extend the line infinitely towards both sides, the point will always follow that line towards both sides. That is the coincidence constraint. It will follow along, it will coincide with this line. In the same way, we can apply the coincidence constraint between two lines. Then we will have to create two lines, one line, and then same way we will create this green tick icon, and then create another line, and then click on it. Now we can use again the coincidence constraint. Now we are using coincidence constraints between the point of a line and between a line. Just click on the point of a line and then click on another line. Now you can see that this line will follow that line along the line. If we extend this line towards both sides infinitely, then this line will always follow that line. It will always coincide with that line. This is the coincidence constraint. Now you can see this line. You can rotate it around in the 360 degree, but we are using constraint to limit its movement. That is constraint to limits the movement of the any shape or any line, that any point, any angle, arc that we create, we have to restrict its movement. That's why we use constraint. So in this line we can rotate it 360 degree. So we want to restrict its movement along one axis, along the horizontal axis or the vertical axis. So then we can use the horizontal and vertical constraint. Then if we use this icon and click on that horizontally, it will get horizontal and vertical constraint. If we apply that, now you can't able to rotate it 360 degree. Now the line has become restricted to the vertical axis. In the similar way, if we align a line that is closer to the horizontal axis and then we apply a constraint to it, then the line again will become aligned to the horizontal axis. Now you can't able to rotate this line anymore. This is the horizontal and vertical constraint. If you want to know which constraint it has applied, you can click on this icon, and here you can see that it has used the horizontal constraint. Similar way, if you click on this icon, that you can see that, check it out, that which constraint it has used. It has used a vertical constraint. So let's move on to the another constraint, that is perpendicular constraint. Similarly, we will create line, two lines. Now we can use the perpendicular constraint between these two lines. Perpendicular constraints means that if you apply this perpendicular constraint between this line and this line, now you can see this icon in both of that is the perpendicular sign, means that both is perpendicular to each other. In previous we have seen that we can get rid of any of the constraint that you can see in the cursor, get rid of using the escape key in the keyboard, or we can get rid of that by right clicking the mouse button or clicking on OK or cancel to get rid of that. Now what is the perpendicular constraint? Now you can see if we move that line, it always remain aligned to that line, means it always remains perpendicular to that line. It always remains perpendicular. Both lines are perpendicular to each other if you extend it infinitely. That's the perpendicular constraint. And if we want to align this line together, we can use the previous coincidence constraint, and then we can use the point and the line, then the both point. Now you can easily able to see that the both lines are perpendicular to each other. If we are able to rotate it, it always remains perpendicular. This line and this line always remain. That's the perpendicular constraint, means that the angle between these two lines always remains 90 degree. And you can check that perpendicular constraint by clicking on any of these two icons, and then you can check it here which constraint it has used. It has used the perpendicular constraint. So let's move on to the next constraint, that is the collinear constraint. Collinear constraint means if we create two lines, one line and another line, and if we will use a collinear constraint, then this line and this line will align itself and become a single line, always follow a single line, will be aligned in a single straight line. That we have applied the collinear constraint, the line has aligned in a particular direction, become the same line. If we create another line, and if we use a collinear constraint, means both line, and if we want this line to align with this line, these two both lines, we can use the collinear constraint. Just clicking on that one line and then another line, this third line has become collinear, means it's become in the straight line, follow the same line. This is the collinear constraint. So what is constraint? As we have seen earlier, the horizontal coincidence constraint, collinear constraint, and the perpendicular constraint somehow try to restrict the movement of the line that we have created, that try to restrain and constrain the movement of the lines. That is the constraint, to limit and restrict the movement. That's our aim in creating any sketch. So let's start creating our main sketch that we have discussed, the the part 1 red sketch. So open up that PDF. So open up this PDF, and as you can see, this is the sketch that we are going to use. We will create the basic structure of this sketch in the first part. So let's start creating our basic structure of this shape. This is the top view. So to create the sketch, just click on the line tool and then create the basic structure of that part. It can be rough sketch. Now moving on, we first have to use the constraint. Before using this dimension tool, we have to first use this tool's constraint tool to, so this line we can use the horizontal and vertical constraint on this line. As you can see, the Fusion 360 has automatically allocated the different constraint, the perpendicular constraint and the vertical constraint and the horizontal constraint, automatically allotted these types of constraint. We don't have to use the perpendicular constraint now. And this line are along the same line. This and this line will along the same line, so we can use the collinear constraint here by using the clicking on this line and then clicking on this line. Now you can see the both line will follow along that we have used the collinear constraint. That if you click on this icon, then it will show the collinear constraint. And if you want to get rid of any of the constraint that you don't want, then click on the constraint icon and then click on delete. Then you can able to get rid of that icon. So we want that, so we can undo that using the basic control Z to undo things. Now we basically have used all the constraint that we can use. Now we can use another function, that is dimension, to dimension each and every line. So now you can open up the PDF. Now we can use this dimension, it is given here, to dimension our sketch. These are all in millimeters. So we can use the dimension constraint to dimension this line. This is the 31.7 and then hitting enter. But you can see that the shape has been distorted and the shape can't has resize. For that we have to change some setting here. Then click on top right icon and then click on preferences. Inside that preferences, go to general, and in design you will see a setting of scale entire sketch at first dimension, and then click on that and then click on apply and then OK, and then undo for this step that we have given the dimension, and then click delete this. Now use the dimension sketch again and then enter the 31.7 and then hit enter. Now you can see the entire sketch has been resized according to this dimension. That was the setting that we have changed. Now you can give dimension to each and every length. Now we can use another constraint, that is the equal constraint here, sketch, to constrain this sketch. We can know that this and this length are equal, so we can use the equal constraint on this thing to become equal. Now we don't have to dimension this length. In the same way, this and this all are equal, so we can use the equal constraint here also between this and this length. Now this and this all three has become equal. Similarly, we can use the equal constraint between this and this length. As you can see, there is one error has occurred. The sketch geometry is over constrained, means this already this and this point are equal because of the collinear constraint and the perpendicular constraint. It has become automatically has become, these two lines have become equal. So we don't have to use the equal constraint here, but we can use this line and this line. This have become equal. This and both lines are equal. Now we can dimension this again. And this length is 8. These are all also equal.
this length are equal, this length and this length are equal. Now we have to dimension only one part, this one. This and this length are also equal. Now you can see that the sketch has been can't able to move the sketch anymore, means this all has been become constrained. Now the only problem is that the sketch is freely able to move. We don't want that, we want the sketch to stay in the same position. So here we can use the coincidence constraint between this point and the origin. Now you can see that the color of the sketch has changed. Now it has become black. This indicates that we have fully defined the sketch, or we can say that we have fully constrained the sketch. You can see by the lock icon because beside sketch indicates that the sketch has been fully defined and the fully sketch. Now you can't able to move any of this point. This all indicates that the sketch has been fully defined. That's our aim, that we have conquered. Then click on finish sketch. Now rotate this icon and then we have to extrude this. You can extrude this sketch by clicking on this extrude icon or just clicking on the plane and then right clicking and then clicking on extrude button and then extruding it. And what is the dimension of the extrude? You can check it from here. This is the length 7.8. We have to extrude. Then enter 7.8 and then hit enter. So we have created the bottom part. This part we have created. Now the next part it is left to create the top part. So we have to create the sketch for that. So we have to create the sketch top of here. So open up this sketch. So we have to create this top part. To create this top part we have to create this sketch. So we have to create the rough sketch first. So we will create a sketch top of here. So select the top face and then right click and then select the create sketch. Now we have to create the rough sketch that we have seen. So to create the sketch, just click on the line tool and then click on one point and then create the rough sketch. So now the next thing we have to do is to use the constraint. So here we will use the equal constraint. And the equal constraint, this and this length are equal. As you can see in this the 15.8 and 15. These two lengths are equal and these two lengths are also equal. So we will use the equal constraint between these two lengths and then it will make it equal. So when you try to make this length and this length equal, an error will occur. The similar error occurred before, that sketch geometry is over constraint, means that these two lengths are already equal, so we don't need to make it equal again. So similarly these two lengths are also equal. If you try to make these two lengths equal, again it will show that the sketch geometry is over constraint. This means that these two lengths are equal, already equal, so we don't have to make it equal again by using the equal constraint. Now the next part is to use the sketch dimension. So we will dimension the top length, which is 15.8, and then hitting the enter. Now you can see again that the sketch has turned, all the lines has turned black. This shows that the sketch is fully constrained, as you can see from here also by the lock icon. If you delete, for example, if you delete this dimension, now you can see that the lock icon has gone. This indicates that the sketch is not fully constrained. So the lock icon indicates that the sketch is fully constrained and we want that. So then click on finish sketch. Now go to the normal view by clicking the home icon. Now we have to extrude it. So click on the sketch and then right click and then click on extrude.
then extrude it up, and see in the sketch was the extrude we have to do, which is 8 millimeter, and then giving it 8 millimeter and then hitting the OK button. Now you can see that the sketch we have created the part, this part we have already created. Now the only thing is left is to round off the edges. To round off the edges, we will use a tool that is known as fillet. This tool, fillet. If you click the edges, multiple edges, and then giving it, for example, 1 millimeter of fillet, it will round off the edges that we have selected. But we can see that in this part that each and every edge, we have to select each and every edge to round off each and every edge. So we can do again the fillet again, and then clicking the individual edges again, or there is one shortcut that we can use. We can undo this fillet by click Ctrl Z. So to select every edges, just go on to the top icon, select, and go to the selection filter, and make sure that select through is tick, and then deselect the select all, and then select the body edges. Now hold down the left mouse button and drag it. Make sure that the square covers hold the body, and then let it go. Now you can see that each and every edges of the body has been selected. Now we can again go to the fillet. Now you can see that the 47 edge, all the edges of the body has been selected. Now we have to give the fillet of 1 mm, and then clicking on OK. Now we have created our first part. The only thing is left is to color with red. So for coloring it, you can select the part 1 red and then right clicking on it and go to the appearance, and this will open up the appearance dialog box. We have to go to the library section. Inside library, we have to select the plastic, this plastic folder. Inside plastic, we can see different type of plastic that we can use, but here we are using this ABS white plastic, and then click on it and drag it over the part. Now you can see that the color of the part has been changed. Now we want the red color, so to change the color, just again go to the ABS white icon, and then right clicking on it and then click on edit, and then you can drag this to change it to red, and then click on done. Now we have created our first part. So the next thing is I want you to do is to make the part 2 orange, this one, using the sketch, using the same concept discussed earlier, and the part 3 blue, using the sketch and the same concept. I can give you some hint how to make this. Start with the sketch and then extrude it up, and then same again, create another sketch top of here, and then extrude it again, and then add the fillet. In the similar fashion, you can create this blue part also. These are easy, you can do it. So before moving forward, that we have selected earlier the selection filter. Make sure that we select the all again. In the previous video, we have created this part 1 red, and I have given to create the part 2 orange and the part 3 blue. Hope you have tried to make it by yourself, this orange part and the blue part. Those who have got stuck while creating this part, I will give you the solution of part 3 blue, and I recommend those who have completed this part 2 and part 3 still to watch this video, as the new concept will be given in this video. So to create this part 3 blue, just open up the cube puzzle that we have created in the last video. So to open that up, just click on the show data panel icon, and then go to the home icon, click on it, and then inside all project files you will see that Learning Fusion 360 file. Just double click to open up, and then click on the project one to open it up, and then click on the cube puzzle, double click to open that up, and then to create the part 3 blue, just click on the new component and then name it part 3 blue. And then hit enter. Now you can see that the new component had been created with the name of part 3 blue, and this is the previous part 1 red that we have created. And to hide the part 1 red, just click on the eye icon. So let's start by creating the sketch, bottom sketch. Click on create sketch and then choose the bottom plane. Then open up the PDF drawing of part 3 blue. So this is the part 3 blue, the bottom sketch of the part 3 blue. So we try to make the rough sketch of this bottom plane. So choose the line tool and then create that line. So you can see here that if you try to make the line straight, you can see by the blue sign indicated on the line that the horizontal constraint is being allocated to that line. If we try to make it at any angle, the horizontal constraint is gone. So if you try to make it straight, you can see that the horizontal constraint is being allocated to this line. In the similar fashion, if you try to make the line straight at an angle to that line, you can see that a 90-degree angle is being allocated to this line. If you try to make it at any angle where the 90-degree angle is gone, then you can see that if you try to make the line straight, then a perpendicular constraint is being allocated to this line. In the similar fashion, we can allocate and try to make it straight, or it will Fusion 360 will automatically allocate a constraint to that line. So now we have created the rough sketch, and to get rid of the line tool, just click on the escape key on the keyboard, or click on the right mouse button and click on OK or cancel. There are two ways to cancel that out. So now the next path is to fully define the sketch. That's our aim in the sketch workbench, is to fully define the sketch. What is to fully define the sketch? As you can see that the sketch is now freely able to move in any direction. That we don't want. We want the sketch to be fixed. It can't able to move it anymore. So to achieve that, we use the constraint tool and the dimension tool to fully define the sketch. So we will start by choosing the constraint tool at first. So we can use the equal constraint here. As you can see that this length and this length are equal at 31.7. In the similar fashion, this length and this length are equal, and this length are equal. So we can use the equal constraint on that. This length and this length are equal, this length and this length are equal, this length and this length are equal. And then click on escape key. Now we can't use any more constraint here. I think we have used all the constraint that is possible to be used in this sketch. So we next move on to use the dimension tool. So we have dimension this length. What's that length? That length is 31.7. So 31.7, and then hit enter, and then zoom in, and then this length is 7.8. In the similar fashion, this length is 15.9, and this length is 8. So when you try to make that length equal to 8, it will try to show that the sketch is over constrained. This means that the sketch has already become 8. You don't have to make it 8 again. You can see it that sketch has already become 8 by the driven dimension. Then click on the driven dimension. You can see that the sketch length is 8. The driven dimension is for reference purpose only. It means that this dimension is not driving the sketch. It's for reference. It's like measuring this length. It's shown by the bracket inside the 8. means that the sketch is not, it's for reference purpose only. It means it's measuring this length. You can measure any length. You can use the driven dimension in any of the this length. You can use here also. You can use the driven length, and you can see that this length and this length are equal. Is for measurement purpose only. Then click on escape key. So now when you try to move the sketch, you can see that the sketch is still movable. So we have to fix that. We have to fix this movement with respect to the origin. So we can use the coincident constraint between this point and this point. As you can see that the sketch has now turned into black. That's our aim, to make the sketch fully constrained. Now you can see that the sketch can no longer able to move any point. That's what I was talking about. So why we need to fully define the sketch? If we not fully define the sketch, if we try to make any changes in the future, it might break the model or might throw off the sketch. So we need to fully define the sketch. So in the future we can easily able to make any changes in the sketch or the model without breaking it or throwing off the model. So then click on finish sketch. Then click on the home button. Now we have created the 2D sketch. Then how we will create the 3D sketch out of the 2D plane? Yes, we have to extrude that out and then extrude it up. And what is the length? 7.8. So now we have created the bottom part. So we have to create the top part, this top part. So this is the sketch of this top part. So we have to create this rough sketch of this top part first. So to create the sketch on, we have to create in top of here. Just right click on it and then click on create a sketch. And then choose the line tool again. And then we are trying to start the line from this point. So you see that when you try to move the cursor near the point, Fusion 360 is trying to snap it to that point. Similar fashion, it is snapping to that end point, and then we can create that rough line. So we can create another in the similar fashion. It is being snapped to this point, and then again. So to get rid of the line tool, just click on escape key. So now we have to use the constraint first. So we can use the equal constraint between these two lengths as they are equal. As you can see that the squares are already turned to black. So we will choose to dimension this. So we will try to dimension this length. So again the sketch is showing that this length is already been defined. So we don't have to define it by showing that the sketch is over constrained. You can see that we don't have to define this length. You can check it out by clicking on the create driven dimension. So we don't have to define this length as 7.8 as it already been defined. So we have only need to define this length, which is 15.8. So we have fully defined this two length. So we now can create on finish sketch. Now the next part is similar. Just create on extrude tool and then click on the extrude button here. So now here you can choose multiple extrude all at once. So you can choose extrude profile 1 and the second. Both are selected, and then we can drag it up and add the length of 8 and then hit enter. Now we have created our part 3 red. Only thing is left is to round off the edges. That is done by using the similar tool that we have used earlier, that is fillet tool. So how we will select the, if you by mistake select any faces, you can click on this remove select icon. So to now go on to the select each and every edges, just go on to the selection filter, then unselect the select all, and then only select the body edges. Body edges means we are trying to select only the edges of the body, and the select tool will try to select all the edges. Then click on one side and drag it so that the complete body is covered. Now you can see that each and every edges has been selected, and we can add a fillet of 1 millimeter and then hit enter. Now we have created the path. Only thing is left to add some appearance. Just right click on the Part5 blue and then click on appearance. So we can go similar fashion. We will go to the plastic. So you can go to the ABS white and you can download. You can see that this is the download icon. You can download this ABS plastic and then right click on it and then click on add to favorite, so that when we use the ABS white plastic later on, it can be easily be accessible from the favorite tool, and drag it over the tool and then right click on it and then edit and then change the color to blue and then click on done and close that and then hit the save button and then click on OK. So the next thing is creating part 2 orange. So this first thing is to create component, but before creating component, make sure that the cube puzzle is selected. Now click on new component and then name it part 2 orange and then hit enter. Now click on create sketch, choose the bottom plane, hide this part 3. So click on the eye icon. So open up the part 2 orange sketch and create the basic sketch of part 2 orange. Choose the line, then click on escape key. Now use the constraint, the horizontal vertical constraint over here, and then use the equal constraint. You can see this length is on this length is equal, this length and this length are equal. So we can make this and this length equal, this and this length equal. Now you can see that this length is 8, this length is also 8. So these both are equal, and when you calculate the length of the bottom sketch, 15 total is 15.8. You will subtract 7.8, you will get 8 over here, and similarly 8 over here. That means this length and this length and this length all are equal. This sketch geometry is over constraints, means we have already made that equal. So now next move on to dimensioning the length. So we will dimension this length, which is 23.7. This length is 7.8 and this length is, you can see, is already become 8. So we have dimension each and every part. Now you can click on escape key. Now you can't able to select because we have make the selection filter. We have not make the selection filter to all. That's why we can't able to select before. Now we can able to select easily now. Now we can able to move. Similarly, we can make this and this point coincidence constraint, or we can directly move the point over the origin. It will automatically add the coincidence constraint. Now the sketch has turned black. Now we can click on finish sketch and then click on home. Now we can extrude the plane, which is 7.8. Now the next thing is creating this top sketch. So we will right click on it and then click on create sketch and then choose the line tool again and then create a basic rough sketch. Similarly over here. Now next we can use the equal constraint. We can see that the top length of the sketch is 7.8 and this is also 7.8, means both lengths are equal. Similarly this and this length are equal. So we can make this and this length equal and this length equal. Now the next thing is adding the dimension, which is 7.8 and this also 7.8. Now we have fully constrained the sketch. Now next is finish sketch, and similarly we will extrude it. Select the first profile and then select the next profile and extrude it till it, and make sure that the operation is at the joint, and then click on OK. Now the next thing is edit the fillet. So we can again move to the selection tool, then the filter, and then deselect the select all, and then select the body edges, and then select all body edges, and then go to the fillet and add 1 mm of fillet, and then click on OK. Now the next thing is appearance. So right click on the part 2 orange and then click on appearance. Since this, you can see that the pop-up has not come out, but it is over here. You can go to the favorite, add ABS, or you can click on any of the appearance and then click on duplicate. It will duplicate the same ABS file, and then you can click on the duplicate file and then click on edit, and now you can change the color to orange and then click on done. Now open the appearance again, and then now drag the orange color over the part and then click on close. Now we have created the part 2 orange similarly, and then click on save the file. What is 3D printing? 3D printing, also known as additive manufacturing, is a process of creating physical objects layer by layer using a special machine called a 3D printer. It's like building something with Lego bricks, but instead of assembling the pieces manually, the printer does it for you automatically. Here's how 3D printer works in simple terms. First is design. You start by creating a digital design of the object you want to print. This design is made using computer-aided design CAD software such as Fusion 360, or can be downloaded from online resources, for example Thingiverse. Second is preparation. The digital design is then sent to the slicer software like Cura, which prepares it for printing. This involves dividing the design into very thin cross-sectional layers, like slicing a loaf of bread into many thin slices. Third is printing. The 3D printer starts with the bottom layer and begins printing from the ground up. It does this by depositing or solidified material such as plastic, metal, or resin, layer by layer. Each layer sticks to the previous one, gradually building the object. Fourth is finishing. Once the printing is finished, you may need to remove any support structures that were used during the printing process. Depending on the material and design, you might also do some post-processing such as sanding or painting to give the object a polished and refined look. Here are few examples of where 3D printing is being used. Healthcare. 3D printing has made significant advancement in the field of healthcare. It is used to create patient-specific medical implants, prosthetics, anatomical models for surgical plannings. Surgeons can use 3D printed models to practice complex procedures and improve surgical outcomes. Jewelry and fashion. Jewelry designers and fashion enthusiasts leverage 3D printing to create intricate and personalized jewelry pieces, accessories, and even clothing. It offers the flexibility to design complex geometries and unique patterns that are challenging to achieve through traditional and manufacturing methods. Art and design. Artists and designers explore 3D printing as a medium for creating unique and intricate sculptures and decorative pieces. It provides a new level of freedom and complexity in realizing artistic vision. Food industry. 3D printing is Emerging as a technology in the food industry, it enables the creation of visually appealing and customizable food items such as chocolates, cakes, and confection. Chefs and culinary artists can experiment with different shapes and textures, bringing innovation to the culinary world. Aerospace and defense. The aerospace and defense industries use 3D printing to manufacture lightweight and complex components for aircraft, satellites, and missiles. This technology enables the production of intricate parts with reduced weight, improving fuel efficiency and performance. Architects and construction professionals uses 3D printing to create detailed architectural models showcasing design, concept, and helping clients visualize project before construction. Additionally, 3D printing can be used to fabricate building components and intricate structures. Automotive industries. 3D printing is used in the automotive industries for rapid prototyping of cars, parts, and components. It allows for faster design iteration and customization, reducing development time and costs. Some manufacturers are even exploring the use of 3D printing for creating end-use parts in production vehicles. 3D printing allows for great versatility and customization. You can create a wide range of objects from simple toys and jewelries to complex prototypes and functional parts. It has revolutionized industries like manufacturing, healthcare, architecture, and more, enabling faster production, cost-effective prototyping, and the ability to make one-of-a-kind creation. All over, 3D printing offers an exciting way to bring imagination to life, turning digital design into physical objects with the help of a 3D printer. In the previous video, we have created the part 1, part 2, part 3. So the next thing is 3D printing this part. For this, we need to download the slicing software that will make the part ready for 3D printing. There are many different types of slicing software out there, like Ultimaker, Cura, Prusa Slicer, or Simplify 3D. But in this course, we are using a free and open source slicing software, Ultimaker Cura. If you are using any other software, the concept taught in Ultimaker Cura can be applied to any slicing software. So for downloading the software, open up your favorite browser, then search for Ultimaker Cura and then hit enter. Then open up the first link. Then click on download for free. Then choose your operating system. In my case, I am using Windows. And then click download. After you have downloaded the software, just open up the folder where you have saved the file. Then double click to install the software. Then click on next. Then click on I agree. Then choose the destination folder. Then click on next. Then click on install. After installing the software, just click on finish and give allow access. Then click on next, 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 and close. So the next path is sending the 3D model for 3D printing. For that, right click on the part 1 red icon and then click on save as mesh. This will save the 3D model as STL format, which will be acceptable by the slicing software for 3D printing. Then click on OK and then click on save to my computer. Click on here and then choose the folder where you want to save the STL file format. Just name the part you want to save. In my case, I am saving it as part 1 red.stl and then click on save. Now click on save again. This will save the file in your computer as an STL file format. Or you can directly send the part to the Cura slicer without you need to open the software. For example, take the part 2 orange just right click on it and click on save as mesh. In this case, select the Scene to 3D printer utility and then click on Cura. If you have installed the Cura software to its default location, then select that. If you have installed the Cura software at any custom location other than default, then click on custom and then click on the folder and then click on select from my computer and choose the location where you have installed the Cura software and then click on open. In my case, I have installed the Cura software to its default location, so I will select the Cura directly from here and then click on OK. This will open up the part 2 orange directly to the Cura. So for basic navigation of the Cura, for rotating around the model, just right click the mouse button, hold down it, and then you can rotate it around. And similar, you can zoom in and out by scrolling down the middle mouse button to zoom in and out. And to pan around, you have to click the middle mouse button, hold down, and then you can pan around the model. Now you can see that the model is at the corner, and you can move the model by clicking on the model and then clicking on the arrow to move the model around. So next you can sign into the Ultimaker Cura account to backup and sync your setting. So click on sign in. Then if you have already have an account, then you can enter from here. If you don't have an account, then click on sign up. Then enter your email ID. Then enter your password. Then click on next. Then enter your name, username, first name, last name. Then date of birth, then your country, then click keep me up to date and then click on next. If you have Ultimaker or MakerBot printer, you can click on this, but I don't have, so I will click on here to sign in or backup the setting, etc. Then click on create account. So now you can open up your inbox of your email ID to verify your email ID. So the next thing is setting up your printer. So to set up your printer, just click on here, top of here, then click on add printer. If you have Ultimaker printer, then you can click on here. If you don't have, then you can click on here. I don't have, so I have clicked that. Then add a network printer. If your printer is connected to the PC, then you can check it from here. Or if you don't have, then you can click on add a non-network printer. Then search for the printer you have. I have Tavo Tarantula, so I will select that. After you have selected your printer, then click on add, and then click on manage printer, and then select the printer that you have created, and then click on machine setting. Then if you want to change any of this setting, X length, Y length, G length, then you can select from here. And if you want to change the number of extruder, then you can change it from here and then click on extruder 1. You can change the nozzle size and filament diameter from here. So in most of the cases, the default is good. If you don't know what the XYG length, you can Google it, the printer name, and you can find it out, the nozzle size and the XYG length. So the next thing is adding some plugin to enhance the functionality of the program. So to add the plugin, just click on marketplace, and then the first setting you will see the settings guide. If you don't see it here, you can search from here and then click on install. After installing the software, you can see that this plugin will explain each and every print setting in detail. If you don't see this setting, if you see this type of setting, then you can click on the recommended setting. In the future video, we will go in detail in each of these settings. For now, starting out, just click on recommended setting to start with the basic and simple settings. So what is slicing software? Slicing software is nothing but converting the STL file that we have imported for Fusion 360 into many different layers as when we click the slice, and then we click the preview, as you can see that the model has been converted into different layers, different multiple layers, which the 3D printer will print, as seen by 78 layer total, 78 layers, different layer the 3D printer will print on top of one another. This is slicing. Slicing is converting the model into many thin different layers, which is used by a 3D printer in the format of G code. So the next is the setting. So setting is first is the resolution. So what is the resolution? Resolution is nothing but the layer height, different layer heights in millimeters. So what is a layer height? Layer height is nothing but the distance between each and individual layers. As you can see that the distance between the layer 1 and the layer 2 is the layer height, and similarly the distance between the layer 2 and the layer 3 is the layer height. So the layer height, it depends upon the nozzle diameter. So what is a nozzle? This is the nozzle through which the hot filaments come out. This is the nozzle, and the hole is the diameter of the nozzle. So the layer heights depend upon the diameter of the nozzle. There are various type of nozzle diameter you can find out. You can change the nozzle if you want. So various diameter of nozzle, you can see it over here, from larger diameter to the smaller diameter. So for the most of the 3D printer, it's come with a default nozzle diameter of 0.4 millimeter. So the layer height depends upon the nozzle diameter. So the minimum layer height we can consider is 25% of the nozzle diameter, which is, so 25%, so 25% of a nozzle diameter of 0.4, which is 0.1. So the minimum layer height we can consider for a 0.4 nozzle diameter is 0.1, and the maximum layer height we can consider is 75% of the nozzle diameter, which is 25% of a nozzle diameter of 0.4 is 0.3. So the minimum layer height for a 0.4 nozzle diameter is 0.1 and the maximum is 0.3. This is the range we can vary the layer height. So varying the layer height changes the time duration of the printing, the strength and the resolution of the printing. So at a lower layer height, for example 0.1 millimeter, the printer will consume more time, and vice versa at a higher layer height 0.3, the printer will consume less time. So for example 0.1 millimeter, if you slice it, you can see it will take 26 minutes, and at a higher layer height of 0.3, it will take 10 minutes. So it will consume less time, but with a con of lower resolution and lower strength. So vice versa, at lower layer height, it has higher strength and higher resolution. So when we want a model with higher resolution and higher strength, we go with lower layer height. When we want to print material faster, we go with a larger layer height. But for most of the cases, the 50% of nozzle diameter is considered, which is 0.2, which is great, which will take a moderate time with a moderate resolution and moderate strength. So for most of the cases, we will consider 0.2 millimeter. So the next setting is the strength. Inside strength, the first is infill density. So as the name suggests, is the quantity of material inside the 3D model, is the amount of material used. Higher density means higher amount of material is being used, and that lower density means that lower material is used. So for example, take 100% infill and then slice, then go to preview. Now you can see that the material completely filled 100% density. Infill density means that there is no gap between the filament patterns. It's completely filled. And similarly vice versa at 0%, and when we slice it, you can see now that only there is walls around there. 0% infill means nothing, no material used inside. And at the 50% you'll feel that there will be 50% gap and 50% material will be used. So by changing the infill density, we change the filament used, time consumption, density and strength. So at lower density, it will consume less filament and consume less time, will have less strength. Vice versa, at higher density, it will consume more filament, become more dense and consume more time and has higher strength. But for most of our case, we can use 10% to 50% for most of the standard print. In this case, we will consider 20%. So the next is the infill pattern. Is the name suggests, is the pattern in which 3D printers lay out the infill. As you can see that I have selected a triangular pattern, and you can see that the pattern inside is in a triangular form. Similarly, when we goes to the line infill, you can see that the pattern is in the line format, single drawn lines. And in similar way, each and every has different patterns we have here. So the most commonly used pattern that we will use is line, triangular or gyroid infill patterns. So changing the infill pattern also changes the strength and the time consumption of the print. So for less time consumption and a standard strength, we can use line or triangular infill for most of the cases. And when we want a higher strength 3D model, we can go with a gyroid infill. So the next thing is cell thickness. So what is cell? So when you make the infill density 0, what's left of it without the infill density, this is the cell, or you can see the walls. You can also call it wall or parameters. So what is the cell thickness? The thickness of the wall is the cell thickness. So the cell thickness depends upon the nozzle diameter. As we have discussed earlier, in a standard 3D printer, the nozzle diameter is 0.4. So when 3D printer starts printing a single line, so the width of the single line is 0.4 of a 0.4 nozzle diameter. If it has 0.6 nozzle diameter, then the line width will be 0.6. So the width of the 0.4 nozzle diameter of single wall will be 0.4. So there are two walls, so the width will be 0.8. As you can see, the cell thickness width is 0.8. If we want 3 walls, then we have to multiply 0.4 by 3, which will be 1.2. As you can see, by changing the thickness, we have changed the number of walls. Now it has 3 walls. So always keep in mind that the cell thickness will be multiple of the nozzle diameter. If we want 3 or 4, then we have to multiply it by the nozzle diameter of the printer. By changing the cell thickness, we change the strength of the 3D printed part and the time duration of the 3D print. So for normal 3D printing part, we use walls of 2 to 4. So if we want to print faster, we use 2 walls. If we want the 3D printed model have higher strength, then we can use 4 walls. In this case, the part doesn't require to be much stronger, so we will use 2 walls, which will be 0.8. This is the side wall thickness, side one, and this is the top and bottom wall thickness. Top and bottom wall thickness. So the next thing is support. In this part, we does not need support, so leave it for now. So the second thing is adhesion. As the name suggests, it will help the 3D printer model to stick to the bed easily. This is the adhesion, as you can see by the blue filament. If we remove it, then the adhesion will be gone. As you can see, there is only the side one. So in this part, we does not read adhesion. So the next thing is selecting the material. So go to the top and then select the material that we are using. So at first we are using PLA, which is the most used material for 3D printing which is easier to print. So for starting out we will use PLA. So choose the manufacturer of the material that you have purchased. So in my case I'm using generic and then select PLA. If you have any other manufacturer, just click on it and then select PLA and then choose the PLA manufacturer. So if you have different color filament, you can print all the different parts with different color separately. So this is part 2 orange. You can slice it and then save it to the disk as a G code, and do the same with each and every part 2 and part 3 same. If you don't have the filament of different color, you can print it with the same color filament by opening the part separately one by one and now slicing the part and see the preview once before printing, and then save it to the disk as a G code. So if you want to print part 1 and want to remove this two, just click on it and hit delete selected. Click on it and hit delete selected. It will remove the part. Now you can slice it and print it separately. In this video we are going to create this part 5 yellow. So I want you to pause the video and think how you are going to create this part. So as discussed earlier, you can create the parts similar as we have created the part 1, part 2 and part 3 by creating the first bottom sketch and then extruding it, and then creating a top of sketch over here and then extruding it again and then adding the fillet. You can create by this method, but in this video we are going to create this part by some different method. So let's understand some new concept before moving on. So as discussed earlier, that the extrude function can be used to create solid component when you extrude, but is also used to remove or cut component. If you drag down the sketch below the solid component, you can see that it has been cut, the component has been cut out, it has been removed from the solid part. That means the extrude function can be used to create solid part, but it is also used to remove solid component. Now below you can see this is what is called a timeline. Everything we have done is been recorded over here, from the sketch that we have created to the extrude and sketch, and everything has been recorded here. This is what is called a timeline, and this is the marker. You can roll back in the history and see that we have first created the sketch and then created the extrude and then created the sketch again and then extruded it again. So this is what is called a timeline. So you can able to change or modify any of the design that we have done by right clicking on any of the function and then clicking on edit feature. If you want to change the extrude, you can do it from here and then click on OK. Similarly, if you want to change the sketch, you can also do it by right clicking on it and then clicking on edit feature and then changing the sketch and then clicking on finish sketch, and you can see that the design will automatically modify itself. So it's the timeline. You can able to modify any of the design that we have done in the past history. So you easily able to modify the design if you want to. So it's a great feature for changing the design. So you can see that the operation is at the cut, which is to remove the component. But if you change the operation to join, the cut will be converted to the solid again. So is this the two operation, the join and the cut is the most common operation that we use for the extrude function. So the concept discussed earlier, using that concept, the extrude and the extrude cut, we will create this part. So to create the part, just open up the cube puzzle that we have created, the part 1, part 2 and part 3, and then select the cube puzzle by this and then create the new component and then name it part 5 yellow and then hit enter. And to hide all of these all at once, you can right click on the part 5 yellow and then click on isolate. It will automatically hide all the parts, part 1, 2 and 3. So let's move on to creating the sketch. So just click on create a sketch, go to home and then choose the bottom plane. Now open up the part 5 yellow PDF. So we are going to create both sketch all at once, bottom sketch and the top sketch. Previously we have created the bottom sketch differently and then top sketch on different plane, but in this method we are going to create both sketch all at once, so we don't have to create the top sketch later on. We can use this sketch to create both thing. So let's start creating both sketch, top and bottom sketch all together in the single plane. So then create the rough sketch by choosing the line tool and then create the rough sketch. Now we can use the constraint tools. First we will use the horizontal vertical constraint here. So when we used all the constraint, so we will next use the equal constraint. So we can see this length and this length are equal and this length and this length are equal, means all three are equal. So we can use the equal constraint here and here, and then equal constraint between this and this. Similarly this length and this length are equal, so we can use equal constraint between this length and this length. Now we can use dimension the sketch. So choose the dimension tool and then dimension this 7.8, zoom in and then dimension this length 31.7 and then dimension this length 23.7. So to dimension this 8.1, you can choose this length and this length and then you can dimension it. Similarly here you can dimension by choosing the top length and then this length and then dimension the 8. So this length is also 7.8. This is a square, so this is 7.8, this is also 7.8. So we can use equal constraint here also, but also there is also one method to make something equal by using a dimension tool. Just click on the length that you want to make it equal by selecting this to length and then clicking on the dimension you want to make it that. So we want to make this 7.8 this length, so we can click on this. If you want to make it some different length, then you can click on that particular dimension. You can, if you click on 7.8, you can see it had dimension this, and when you hit enter, you can see that it has become 7.8. Means if you change this length, it will automatically able to change this length. Means this and this length are now related, or you can say that equal. Now you can see that the sketch has fully turned black, means it has become fully constrained. So now we can click on finish sketch, then click on the home view. Now we can extrude the sketch. So now we are going to extrude the sketch. So we are going to extrude all the sketch till here, which is 15.8. So select the extrude tool. So you can select individual profile one by one, or you can select all at once by holding down the left mouse button and then dragging it. Selected every profile, which is 6 total profile. Now we can extrude it to 15.8 and then hitting OK. So after making the extrude, we have to make the cut in the part, just like these cuts. So we can create the sketch top of here, or we can use the previous sketch that we have created. Just click on the right side, click on the part 5 yellow arrow beside yellow, and then click arrow beside sketch and then unhide the sketch. Now you can see the bottom sketch. So we can use the bottom sketch to cut the part on top of here. So to cut out the part, just click on extrude and then choose the profile. Choose the profile that we want to cut. You will want to cut this and this profile that we have created, but we don't want the cut to start from here, from this plane, but we want the cut to start from the top of the plane. So in the start of the extrude, we will choose from the object, and then we can choose the plane that we want to start the sketch from. So we want the sketch to start from this plane. Now we can drag it down to make the cut, and then we can make it -8. Now we can click on OK. Now you have seen that we have created the cut edge here. Only thing is left to fillet the edges. So we can fillet the edges and then go to select and then selection filter, select all body edges and drag it, select all the edges and then 1 millimeter of fillet and then click on OK. And the next thing is appearance. Right click on part 5 yellow and then click on appearance. Then duplicate any of the color in design. Then click on it and then click on duplicate. After duplicating it and then click on it and then click on edit. And then change the color to yellow. And then click on done. And then drag the yellow color over the part. And then click on close. Now you can save the part. Now we have created the part 5 yellow. The next thing is creating the part 4 yellow. So this is the homework you have to create. You can create by the method that we have given in this, by creating the extrude and then creating the cut as we have discussed in this video, or you can use the method that we have discussed on the previous to creating the previous part. Create every part and then print out part 1 to part 5. The next video we will assemble the part 1 to part 5 puzzle. So in this video we will do assembly of project 1 cube puzzle. So hope you have created part 4 given in homework in last video and printed out all the parts through Cura and the setting discussed earlier. So this is how my parts are turned out from part 1 to part 5. So let's do assembly. For that, open up the drawing PDF and go to the last assembly page of project 1. Using the help of assembly photo, we will assemble the puzzle. So let's get started. Let's start by yellow part. Let's first align this according to PDF. Then blue part, align this similarly and join this with the yellow part as shown. Then move on to white and yellow. Align this similarly as in the PDF and join it together. Then join the white and orange and yellow and blue together as shown. Then the last one, red, align this, then join this too. So we get our first project completed, cube puzzle. So hope you enjoy learning by building. In the similar way, we will make many fun projects step by step, creating from simple to complex one while learning the Fusion 360 concept along the way in the coming videos. So have a great day. So hope you like and enjoy the course till now. If so, please like and share this video with others and comment on things you want in this course and give any suggestion from improving this course. You can enroll in the complete course from link in the description. This course is for pre-sale now. Whole course will be available soon. Enroll today to get early access to the next project. Thank you. Have a great day.